In this lesson, we're going to look at how the discriminant helps us to find conditions for tangency and if a line has a tangent to a curve. So to determine how many times a line intersects a parabola, we can substitute the equation of line into the equation of the parabola. That's nothing new. When a quadratic equation results, the discriminant can be used to find the number of points of intersection. So here's some diagrams and some illustrations. So b squared minus 4ac is greater than 0. We've been talking about parabolas crossing the x-axis and saying that, okay, it has two roots. The same idea, if you've got a line meeting a parabola at two places, then the resulting equation, if you take the discriminant of this and it's greater than 0, then the line will hit the curve twice. If you take the discriminant of this resulting equation and it equals 0, then just as the parabola touches the x-axis once, this will touch the line once, which will be the situation where a tangent arises. And if b squared minus 4ac is less than 0, then the line and the curve don't intersect at all. So we can use this fact to find out if the line's a tangent to the parabola. So let's look at an example. Prove that the line y equals 2x minus 1 is a tangent to the parabola y equals x squared, and find the point of intersection. So the first thing we have to do to prove the line's a tangent is to find out where they cross. So the line and parabola meet when y equals y. Now I tend to always write the x squared part on the left hand side. I always usually like x squares being positive. It doesn't mean you can't deal with them as negative, but it's easier when they're positive. So if you write that first, then you take everything over to the side of the x squared, and it's much easier to deal with. Because we've got a quadratic equation here, and the way to solve it is get everything over one side and let it equal 0. So the line and parabola meet when x squared minus 2x plus 1 is equal to 0. So we're trying to prove the line's a tangent, so we use the discriminant here. A, negative 2 is b, and c is 1. So b squared minus 4ac equals negative 2 squared, take away 4 times 1 times 1, and that comes to 0. Negative 2 squared is 4, take away 4 and you get 0. Hence the line's a tangent. So from the previous screen, when b squared minus 4ac equals 0, the parabola and the line meet at one point and one point only. Now to find the point of intersection, we've got this part here, and then we can factorise to solve it. Okay, so I'll rewrite that down here. So factorising this, you get x's at the front, and then you get 1s, a 1 and a 1. It needs to be a negative 1 and a negative 1 to make your negative 2 here. This also helps us understand that there's only one point of intersection. If we had different values here, there would be 2 points of intersection, so that wouldn't work. So x equals 1. To find the y coordinate, you can substitute it into either one. So x is 1, then 1 squared y is 1. If x is 1 up here, 2 to gain 1, y is 1. Okay, so point of intersection, 1, 1.